writing the equation of a perpendicular bisector to a segment. If we draw a segment, what we are trying to accomplish is find the equation of the line that divides this segment into two congruent pieces, or two pieces of equal length, and runs perpendicular to it. So bisection, cut in half. And to write the equation of this blue line, we need two pieces of information. And that goes for any line. So equation of line requirements. We need one, the slope, and two, a point it passes through, or a point on the line. And the order in which you find them does not matter. But for a problem like this, the point it passes through, or the point that is on the perpendicular bisector that we are going to use, is very specific. And how we find the slope also is going to be coming from pieces of information about the original segment. So for the point on the line, the point we can identify that it passes through is the midpoint of the segment. And the reason it has to pass through the midpoint is because we're asked to find a perpendicular bisector. So that term bisection, we know it has to be cut in half. So what point is right in the middle of the segment? It would be the midpoint. And as a reminder, to calculate a midpoint in a coordinate plane, when we're given locations for the end points of the segment, we are simply going to average the x values and the y values. So here's our midpoint formula when given the endpoints of the segment. Now, once we have the point it passes through, or the point on the line in which we are trying to write the equation for, we now need the slope. How are we going to get the slope? Well, again, we're given the location of the endpoints of the segment. So therefore, we can find the slope of the segment. And knowing the slope of the segment will give me the information needed to find the slope of the perpendicular bisector, because I know that to find a perpendicular slope to a given slope, we just take the negative reciprocal of that number. So for the slope, it's going to be the negative reciprocal of the slope of the segment. So let's say that m is equal to the change in y over change in x. And let's say m, and we'll put a subscript for segment. And let's say that this ends up equaling some value a over b. Well, then the perpendicular slope will equal negative b over a. So you take the opposite sign and take the reciprocal of that value. So that's the overall approach. Now let's look at an example. Let's say we are given a segment with endpoints -4, 5, and 6, -5. So we'll say A is at -4, 5, and B is at 6, -5. Actually, let's do a more interesting example. Let's say we have 3, 2, and y is at 5, 10. So if we're on a coordinate plane, and we have 3, 2, the location of x, and y is at 5, 10, we can see that we can connect these 2 points to form a segment. So if we want to write the perpendicular bisector to this segment, first we need to find the slope, or the point that my perpendicular bisector is going to pass through. And again, the point that it passes through must be the point that cuts this segment into two equal pieces, and therefore it must pass right through the middle of that segment. And that middle point is the midpoint. So let's calculate the midpoint. We're going to average the x's, and we're going to average the y's, and we will have a midpoint of 4, 6. Now, to make sure that that math checks out, let's plot 4, 6. And that does look to be right in the middle, despite some scaling issues that I may have through a freehand coordinate plane. But you can see that this calculation looks like that should be the midpoint location. Now let's find the slope. So again, we're going to find the slope of the segment because we have information that will allow us to calculate that. So the slope of the segment, we're going to do the change in y. So we're going to do 10 minus 2 or 2 minus 10. The order doesn't matter as long as you stay consistent between the 2 points. And then 5 minus 3. So change in y over change in x, we're going to get 8 over 2, which is equal to 4. Now this isn't the slope of the perpendicular bisector, so make sure that we carry this through. The perpendicular slope is going to be the opposite sign and the reciprocal. So the negative reciprocal of that value, which would be negative 1/4. And to check to see that your slopes are perpendicular to each other, if the product of two slopes equals negative 1, then those slopes are perpendicular. And if I multiply 4 and negative 1/4, I get negative 1. And the only case where that would not work is if you had a vertical and horizontal line, because their product would be undefined. Now, we have a slope, we have a point it passes through. So let's write the equation of our line. To write the equation of the line, we're going to use point slope form. So we're going to say y minus the y coordinate of the point on the line, which is 6, is the slope, x minus the x coordinate of the point it passes through. So there's the equation of our line. This is the equation of the perpendicular bisector. We can solve for y and put it in, or we can just plot that point, negative 6, and then count off the slope just to see if this thing looks right. So slope negative 1/4. So scaling might have ruined this for me, but they're supposed to run perpendicular to each other. So there's the equation of your perpendicular bisector in point slope form. If we want it in slope intercept form, no worries, we just solve for y. And there's your answer. So that is how you find the perpendicular bisector to a segment.